Good morning. Today we're going to cover 5.3, which is solving linear systems using a new method called elimination. So you've already had one algebraic method, substitution, and you're going to learn a new one today. So if you haven't done it already, please do the getting ready, the mind's on, for lesson 5.3. So today's learning goal is to be able to use the method of elimination to solve a linear system. Remember, solving a linear system means find the point of intersection of the two linear relations that you've been given. All right, let's do that mind's on, see how you did. So it specifically tells you that you have to use substitution here, not graphing, because that's the other method that you already know. So for substitution, we know that what we want to do is we want to isolate one of the variables. And I'm so nice that I already gave you one of the equations with a variable isolated. So we don't have to do any rearranging there. So now I'm going to take that expression for y, and everywhere there's a y in the other equation, I'm going to replace it with my expression for y. So I'm going to say x plus 3, and instead of writing y, I'm writing the equivalent expression for y plus 3 equals 0. So x plus 6x minus 3, I'm just getting rid of the brackets by doing the distributive law here. So 6x minus 3 plus 3 equals 0. All right, well, let's gather up our x's on this side. So that's going to be 7x. And let's gather up the numbers. We may have to move them. Oh, look, minus 3 plus 3 is 0, and we still have a 0 over here. Well, if we moved that 0 over and we subtracted 0 on both sides, it's not going to make any difference. This side's going to be 0, and this is just going to be 7x. Interesting. Okay, so now we're going to divide both sides through by the 7 in front of the x. And you're going to end up with x equals 0. Okay, now what we want to do is we want to sub x equals 0. I'll just write it out for you. Into, doesn't matter which one, but I'm going to number them here 1, 2. I would substitute it into 2 because it's already in y equals form, so you're just going to say y equals 2, x minus 1, y equals 2. Our value for x was 0, so we get y equals 0 minus 1, and y is negative 1. We do need to check our answer. So we can just, at this point, maybe because I don't have much room, we can say, so a possible solution, written as an ordered pair, x then y, is 0, negative 1. Let's check. So remember, here I'll just try and separate. Okay, so now we're going to write out our equation in its original form. Okay, we're going to substitute in the 0, the negative 1, and we're just going to work left side and right side. So this is 0 minus 3 plus 3 equals 0, and when we work this out, this is 0. All right, so far so good. Left side does equal right side. Let's use the other equation. Y equals 2x minus 1. We put in minus 1 for the y. 2 times 0 minus 1. That's looking a lot like it's going to give me negative 1 equals 0 minus 1. 0 minus 1 is negative 1. So there we go. Left side does equal right side. So at this point, you want to make a proper conclusion. It's not a possible solution anymore. It is the solution. So you could say 0, negative 1 is the solution to the linear system. Alrighty, so hopefully you got that and you're well on your way with substitution at this point, and let's move on to learn elimination today. So I've given you the steps there. Elimination works by following a very specific method, just like substitution. And the very first thing you want to do is you want to sort of look at your two equations, and if you can, try to find a pair of variables that's the same. And if they're the same, then you can eliminate them. Or if the variables are close to being the same, so one is positive and one is negative, you can choose to eliminate that variable. You'll see what I mean in a second. So when I look at the first example, for instance, what I'm going to do is I'm going to line them up in what I call ax plus by equals c form. Okay? So you're going to have an x, then a y, and then an equal sign, and then a number for each of the variables. So there's the first one, or each of the equations. The second one is also in that form, so that's nice. You don't have to change it. So that's number 2. Okay, so you line it up so that you've got your x's in a column, your y's in a column, your equal signs in a column, and your numbers in a column. And then if there is a variable that is the same, you're going to eliminate it. So when I look at this particular one, I can see that there's an x and an x here. So I'm going to try and eliminate these x's. So I have to decide which operation I'm going to perform on these x's. Am I going to add these x's to eliminate them, or am I going to subtract these x's to eliminate them? And the answer is you're going to subtract them. And so I'm just going to show that operation. So we're going to subtract every column. So if I have x minus x, that's really like 0x, which is just 0. And then I have negative y minus 2y. Well, negative 1 minus 2 is negative 3y. And again, if your integer addition or subtraction is not good, feel free to use your calculators for this. And then 2 minus 8 is minus 6. All right, so 0x is just 0, and so I don't even have to write that. So that term gets eliminated, and I'm left with the minus 3y equals minus 6. And look, I've got an answer for y, because we were able to eliminate one of the variables. I'm just going to divide through by that coefficient of negative 3, and I end up with y equals 2. And from this point on, the method of elimination is exactly the same as the method of substitution. So you're going to sub y equals 2 into either 1 or 2. So which one looks easier? Probably 2, because it has a plus. So we'll write out the equation. And again, you're always going into the original equations to find your x value. So we don't know x, but we know y was 2. So we're replacing y with 2. So this is x plus 4 equals 8. And if I just subtract 4 on both sides, right, I end up with x equals 4. So my possible solution is, remember, x, then y. Where's my y? 2. Okay, got a check. So let's go ahead and, what was x minus y equals 2? So we're going to check for 2. X minus y equals 2. Put the x there, put the y here. 4 minus 2 is 2. Yay. So we've got left side equals right side. Okay. Got to check the other equation though, right? Come up beside it here. So the other equation was x plus 2y equals 8. And if we put in 4 plus 2 times 2 equals 8, we get 4 plus 4 equals 8. 8 equals 8. Yay. Left side does equal right side then. And we can conclude, therefore, the solution to the linear system is 4, 2. Okay, so I want you to go ahead right now and try B and see how you do. Pause the video, please. Okay, so I'm going to line these up one under the other in ax plus by equals c form. So that just means x, then y, then number. There we go. I got 1, I got 2, and I'm going to decide on the operation. Now lots of you will have chosen to eliminate the x's through subtraction, but look at the y's. You could have also chosen to add the y's, and you would get the same exact answer. You would just get the x first and then the y, but you would get the same answer. So I just wanted to point that out to you. I will go ahead and subtract the x's because that's probably what you did, and I want you to check your answer against mine. So x minus x is 0x. Y minus y. So that's tricky. 1 minus 1 is 1 plus 1, which is 2. So if I'm writing 0x, I got to put the plus sign. Plus 2y equals, 6 minus 4 is 2. 0 is nothing. So this is just 2y equals 2. You don't need the plus sign. And of course then y is 1. And then we're going to sub y equals 1 into which one? Let's go into 1. So we would get x plus y equals 6, but y is 1. So x plus 1 equals 6. And when we move that to the other side, subtract 1 from both sides, you get 6 minus 1. So x is equal to 5. We're just going to do exactly like we did here. We're going to say, so a possible solution is 5, 1. We're going to check 5, 1, see how we do. So our first equation was x plus y equals 6. When we put in 5 for x, 1 for y, do we get left side equals right side? I'm pretty sure we do. We're going to try again with the other equation, and I can't recall what it was. Let's just have a peek. So that's x minus y equals 4. Again, 5 minus 1 still equals 4. 5 minus 1 is 4. 4 equals 4. Left side equals right side. Okay. So we're going to go and try a harder one now, but that's the basic method of elimination. All right, so let's do a trickier one here. All right, so we've got two variables that look similar but aren't exactly the same. So we've got minus 3x plus 4y equals 7 as our first one, and our second one is 3x plus y equals negative 2. So we've got a 3 and a minus 3. So that's okay, because we're just going to choose, instead of subtracting these two variables, we're going to add the two variables, and that will eliminate it, right? A negative 3 plus 3 is 0. So that's what we're going to do to all of the columns. So 4 plus 1 is 5y, and notice how I'm getting a little more sophisticated now. 7 plus negative 2 is also 5. Not even bothering to add these and put the 0 in. I don't care. It's going to be 0, right? So I'm just going to leave it as 5y equals 5. Divide through both sides by 5, and you end up with y equals 1. We're going to sub y equals 1 into, let's go into 2. So when we, I don't have a whole lot of room here. So when I do that, I'm going to have 3x plus 1 equals negative 2. 3x equals negative 2 minus 1. 3x equals negative 3. And then divide through by 3 on both sides. to get x equals -1. Okay, so my solution is -1, x first, then y. So is a possible solution. We're going to check as per usual. So when we check -1, 1 in each equation, we get, let's see, -3 times -1 plus 4 times 1, does that equal 7? -3 times -1 is 3, plus 4 equals 7, 7 equals 7. Oopsie, 7 equals 7. Left side equals right side. 1 down, 1 to go. 3x plus y equals -2. So when I put in -1 for x, 1 for y, you get -2 equals -2, and left side equals right side. All right. So I want you to now set this one up. Well, maybe I'll set it up for you, but before we do that, I'm just going to go over a basic rule here that you may have already noticed. And that is, if the signs are different, you add. If the signs are the same, you subtract in order to eliminate. So I'm just going to write that up here, to eliminate. If signs the same, you are going to subtract. If signs different, you add. Okay? So I want you to try D, see if you can set it up and decide which operation you're going to perform to eliminate the variables. Are you eliminating the, are you adding the variables, or are you subtracting? Okay, and if you can go ahead and please try and solve that one, and I will do it in a moment. So just pause the video and try D, please. And if you're completely lost, you're not understanding, put up your hand and I'll come and help you. Okay, so what I'm going to do here is I'm going to clear the ink from the page because it's just not, there's not enough room here to do this one. So here we go. We're going to set this up, x minus 3y equals -2. That's our first one. And our second one is going to be 2x minus 3y equals -4. All right, well, I don't have the same coefficient here, so I don't want to try and eliminate the x's. But I can see that I have the exact same coefficient here. And we decided what the rule was, remember, was if the signs were the same, you subtracted. So we're going to subtract. So we have that invisible 1 in front of the x. 1 minus 2, well, that gives me -1x. And I'll just write the -1 in for now, but normally we don't. Do we eliminate this when we subtract? -3 minus -3. Well, -3 minus, that becomes a plus. So -3 plus 3 is 0. So I'm not even going to write it. Now this is tricky. -2 minus -4. -2 minus is a plus, so it's actually -2 plus 4, which is 2. All right, we're going to divide through then by that -1. And we're going to be left with x equals -2. All right. And from here, we're just substituting into either equation, remember? So we're going to sub x equals -2 into, let's go with 1. So we get x minus 3y equals -2. When I put the -2 in there, ooh, there's a lot of negatives. So now we want to get y by itself, but we've got to get rid of the -2 on that side, so we're going to bring it over. We're left then with -3y on the left, and this becomes 2. Oh, that's 0. And we end up dividing through by -3 on both sides. but y will be 0. Okay, so our solution possibly is negative 2, 0. So I'll just, is that what you got? Hopefully I haven't made any mistakes, but we should always check. And I'll just check under here. So check the point negative 2, 0. So if we put it into x minus 3y equals negative 2, negative 2 minus 3 times 0 equals negative 2, negative 2 minus 0 equals negative 2, negative 2 equals negative 2. I feel like I'm saying negative 2 a lot. There we go. That one worked. Let's try the other one. So that's 2x minus 3y equals negative 4. Don't have much room here. So 2 times negative 2 minus 3 times 0 equals negative 4. Does that equal negative 4? Negative 4 minus 0 equals negative 4. Negative 4 equals negative 4. I'm pretty sure then that we've got the right point of intersection. So therefore, negative 2, 0 is the solution to the linear system. Now, I know you're getting tired, but I do have a couple of more examples that I want to go over with you. So here's a couple more where you don't have any numbers that are the same, whether the sign is the same or different. So let's line these up and have a look at them. We've got 2x plus 5y equals 16, and we've got x minus y equals 1. Well, no matter which one I choose, I'm not going to eliminate it when I do addition or subtraction. So I have to manipulate one or sometimes both equations so that I get a coefficient that's the same. So this first one is pretty straightforward. I can see that if I multiplied the second equation, so we'll call this 1 and call this 2, if I multiply the second equation by 2, then I would have the x's the same. Or if I multiplied the second equation by 5, then I would have the y's the same with different signs, which still means I can eliminate it. Now don't forget, you can't just multiply one of the terms by a number. That changes the whole value of the equation. So what I want to do here is I want to multiply every term. And don't forget the right-hand side of the equal sign. It gets lonely over there. Okay, so don't forget about it because that's a common mistake. So what am I going to do here? Well, I've got the option of either multiplying it by 2 or 5, or negative 2 or negative 5. But I think I'll just multiply 2 by 2. All right, so we're going to take the second one, which means I'm going to keep the first one as is. And I'm going to multiply that second one through by 2. Well, 2 times x is 2x. 2 times negative y is negative 2y. And 2 times 1 is 2. And now we'll call that 3. We've created a new equation. And we still have to decide the operation we're performing on the x's. And because the signs are the same, we're going to subtract. Signs the same, subtract, SSS. All right, so 2x minus x, that's 0x. 5y minus 2 is like saying 5 plus 2, that's 7y. We're subtracting 16 minus 2, well, that's 14. I'm going to divide both sides through by that 7, and we end up with y equals 2. All right, let's find out what x equals. I think it looks better to substitute into 2. You always go back and substitute. I think it's a good idea to substitute into one of your originals. So sub y equals 2 into 2. And so we would end up with x, let's just write this out, x minus y equals 1. And then x minus 2 equals 1. And of course then x is equal to 1 plus 2, or x is 3 when we add 2 to both sides, right? Plus 2 plus 2. All right, so we end up with x is 3, and we have, oopsie, oh well, I'll leave it as red. So a possible solution is 3 and what was the other point? 1, 2? I think it's 2. 2. 3, 2. Okay. I know this gets tedious, but we've got to check it. So we're going to check 3, 2. And we always check in the originals. Always, always. So 2x plus 5y equals 16. Substitute in the 3 for the x, the 2 for the y, and see if left side equals right side. 2 times 3 is 6, 5 times 2, 10. Looks good. 6 plus 10 is 16. And left side equals right side. Okay, let's check that other equation. It was x minus y equals 1 was the original equation. So we're going to substitute in 3 for x, 2 for y. We do get 1 equals 1, left side equals right side. There we go. All right. So I want you now to think about how you're going to try to solve the next one. This one, I'll set it up for you. 3x plus 2y equals 2 is our first equation. Our second equation is 4x plus 5y equals 12. Well, I can tell you right now by looking at this that there's no one number that I can pick to multiply one of them by to get the other one, unless we wanted to work with fractions, which we don't want to. So what you're going to do in this case is you're going to go ahead and multiply this one by, say, 4, and this one by 3 to get 12s in front of the x's. Or you could have multiplied this one by 5 and this one by 2 to get 10s in front of the y's. Or you could have multiplied by the negative versions of those. So lots of options here. You go ahead and pick the one that you want to do, and then but do pause the video, see if you can solve this one, and then come back. Okay, so I am going to multiply 1 by 4 and 2 by 3. So when I do that, I get two new equations, so I'll call them 3 and 4. So I get 4 times 3x plus 2y equals 4 times 2, and 3 times 4x plus 5y equals 3 times 12. So remember, you have to multiply both sides through. And then I'll just clean this up. You can do it in one step if you want, if you can just see what the answers are to each of the terms when you multiply them through by 4. But I prefer to take baby steps. So distribute the 4 through and you get 12x plus 8y equals 8, and 12x plus 15y equals 36. Well, now we have coefficients that are the same for our x's, so that's awesome. Because they're the same, subtraction. So when I subtract, I get 0 there. 8 minus 15 is minus 7y, and 8 minus 36 is minus 28. So when I divide by minus 7 here and here, a minus divided by a minus is a plus, of course. And so we're going to end up with y equals 4. And from here on in, it's just a matter of subbing in the y equals 4. And again, go back and substitute it into the original. Pick 1 or 2. It doesn't really matter. 3x plus 2y equals 2. So we'll go into 1. 3x plus 2y equals 2. All right. So 3x plus 2 times 4 equals 2. 3x plus 8 equals 2. 3x equals 2 minus 8. When we bring that 8 over, Oopsie. Oh dear, what did I do? Sorry. I'm not sure how that's going to affect the video. And then 3x equals minus 6, and divide through by 3, we get x equals minus 2. Okay, so we've got a possible solution. Okay, you've seen many examples today. Minus 2, and what was the other one? 4. We're going to check. So what was the original? 3x plus 2y equals 2. So 3 times minus 2 plus 2 times 4 equals 2. Does it? Minus 6 plus 8 equals 2. I agree. So far, so good. Left side equals right side. Second equation, can't remember it. Go to the original, remember, 4x plus 5y equals 12. So let's check that one. So 4 times negative 2 plus 5 times 4 equals 12. Negative 8 plus 20 equals 12. 12 equals 12, and left side equals right side. So we can conclude. Oh, I think I forgot to conclude over here. Therefore, let's just put that in. 3, 2 is the solution. I'm back to this previous one, to the linear system. So I'll just throw that in now. And then this one, therefore, negative 2, 4 is the solution to the linear system. Okay. I know it was a lot of examples. I hope they were helpful. Please do your consolidate for 5.3 now and start then after that on your textbook work. It should be on your handout. Thanks again for listening.